Alright, so let's review really quickly about our rules for brackets and parentheses. If the endpoint is included, we use a bracket. But if the endpoint is not included, we use a parenthesis. And remember, we'll know about the included or not by our symbol here. For instance, this one says graph x is less than 5. Well, all of the numbers that are less than 5 would go to the left, towards the left, away from 5. But 5 itself is not an actual answer, because you can't say 5 is less than 5. That's not a true statement. So since it's not, we use a parenthesis. In this case, graph x is less than or equal to 5. Well, again, all of the numbers that are less than, we would go towards the left. But because 5 does work in this solution, 5 is less than or equal to 5. In this case, we would use our bracket. Alright, now once we have that down pat, then we can start actually solving these inequalities just like we do equations. All of our same rules apply. You have the addition property, which means you can add anything you want to both sides. We also have the multiplication property, which says we can multiply anything we want to both sides. The only additional rule that we have with inequalities is this new rule. If you multiply or divide by a negative number, you must flip the inequality symbol over. So let's show how this works. Let's look at a couple of examples. Here we have 7 plus 3x is greater than or equal to 2x minus 5. Well, let's move our 2x over to the left by subtracting 2x from both sides. We would really like to keep everything, our letters on the left and numbers on the right in this case. So this is going to make 7. A plus 3x minus 2x would be a positive 1x greater than or equal to negative 5. Now we want to get 7 away from the x, so we're going to do the opposite, which would be to subtract 7. Well, that will cancel that out. So now here we have x is greater than or equal to negative 5 minus 7. Whenever we combine those, that would be a negative 12. So we're looking at all of the x's that are greater than or equal to negative 12. Well, my number line actually did not go out enough, did it? So I'm going to extend it out a little bit. Greater than or equal to negative 12 would mean moving towards the right. So it would be all of these numbers. And because we have equality, negative 12 will actually work in that statement. So I'm going to use a bracket. Okay, let's try another one here real quick. And this one is actually much more involved. But again, our steps are the same whether we're doing equations or inequalities. The first thing we're going to have to do is to do our distribution. So when we do that, we're going to have 5x. 5 times negative 3 would be negative 15 minus 7x greater than or equal to. Distributing our 4, we would get 4x. And 4 times negative 3 would be negative 12 plus 9. Now we combine like terms on each side. So 5x and minus 7x would be minus 2x minus 15 greater than or equal to. Over on the right we have 4x, and we could combine our plain numbers to give us a negative 3. Now let's move our variables to the left. So I'm going to subtract 4x from both sides. So negative 2x minus 4x would be negative 6x minus 15 greater than or equal to negative 3. And now we're going to add 15 to both sides to move that over. So that's negative 6x is greater than or equal to 12. Now we are dividing both sides by negative 6 to get x alone, and because we divide by the negative, we have to flip the symbol over. So our solution set would be everything smaller than or equal to negative 2, so we would get a bracket. Don't forget, if you multiply or divide by the negative, you have to flip the inequality.